Hey everyone, and welcome to Mike Likes Robots. Today we're going to step it up a level by looking at how to use AWS IoT Greengrass to connect a fleet of robots to the cloud. If you're not sure what Greengrass is, I've made a video before. Check it out in the description or at the top of the video. So what are we trying to do here and why? Well, if you've got more than one robot operating at the same location, chances are you're looking at connecting a whole fleet to the cloud at the same time. Now, you could do that by using the same route with IoT Core that we did in a previous video, again, link in the description. But having each robot separately connected to the cloud isn't quite as flexible as doing it through a gateway server. By using Greengrass to power our gateway server, we're taking advantage of everything Greengrass gives us. It's designed to operate on an intermittent network connection. It offers downloading local components like an MQTT server, and it means that we can do things like ML at the edge even when the network's disconnected. It also might reduce costs. IoT Core charges based on number of messages and based on number of minutes a device is connected. By connecting all your devices through one Greengrass server, you're reducing that number of connections to one, which also reduces the number of connection minutes. Also means that we can manage everything using Greengrass from the console. So let's take a look at how to do it. This is another sample made available by AWS, which guides us through setting up a Greengrass gateway server using Docker and connecting a ROS2 robot to it. We can extend it to connect multiple ROS2 robots. And we can see on the page here, I'll link the repository in the description, and we can see this Greengrass setup architecture diagram. Now, what this is essentially saying is that one or more robots can all connect to a server, the Greengrass gateway server, which would be on-site, let's say on a factory floor. Each of them can connect to Greengrass, and then the Greengrass gateway can connect to the cloud. Now, if the network connection between the gateway and the cloud goes down, some of that functionality still works, like being able to pass MQTT messages around locally, or using local shadows or ML at the edge. That's the advantage that we're getting here. So we're going to work through these instructions and see if we can get it working. Let's start by copying this link and cloning it into our repository. Okay, and we'll open the README up, same as we've been using before. And we'll open the preview just to make it a bit nicer looking. So the first thing that it tries to get us to do is to make sure that all of our variables are set from the previous session. Now I'm pretty confident that that is the case because I was careful to save them in the bash RC, but let's run this and double check. So each of them has a value and they all look, yep, they all look good. So let's continue by using this Greengrass setup. First step is to install Docker, and I don't know if that came with the system, so I'm going to check by running hello world. It is not installed, so let's install Docker as a first step. We'll just copy the commands from the Docker site that's linked in the README until we get to the right place. And it looks like we're now installed. So we'll run hello world using sudo, and that is working. So we have access to Docker as sudo, but we don't have access as our current user. Now the way we can do that is by following the post-installation steps. Still not working, so I'm going to reboot. Okay, we're back in. Let's see if we can run it now. And we're now able to run it without sudo access. Great, so let's continue where we left off. We've done this step, so now we're installing the extra dependencies. We've already cloned the repository, so instead we'll just set our repo. I just used pwd to get the current directory and set repo to that. And it looks like we need to recurse submodules, which I didn't do in the original clone command. So we'll just do a git submodule init and a git submodule update recursive. And I didn't remember those commands, as you might have been able to tell from that. But we should now have all of the submodules checked out, including our previous repository that we were working from before for the previous examples. So with that, we should be good to carry on. One thing I will do is save that repo to bash RC in case I need that again in the future. Open it up in code, hit the end, and okay, let's continue. So we need to create a new configuration file. So once we've done that, we have a configuration file that's very similar to our old configuration file, except with a couple more parameters in that are needed for Docker. The cert folder location we already have in bash RC, so we can skip this step. Now we're into the Greengrass configuration. Now there's quite a few steps to this because Greengrass hasn't been set up with this account. So we need to make sure there's a service role, correct credentials, and so on. But we're guided through every step of the way here. Okay, so the instructions say to check for an existing service role. We can see that there's none already attached. So we're going to have to create one. So now we go back to our service roles section and attach the role, and it pops right up. Okay, and with that, we've created the service role that we need. Okay, we'll run these environment variables in the terminal and in our bash RC. And then we'll create this environment file. Okay, and as it says, it allows Greengrass to create a new thing and thing group which it needs to be able to function. Now the Greengrass credentials, it says optional, but because we've got provisions set to true automatically, we do need to set that up. Okay, and we can set the variables that we need in here, which I'll do off camera. Okay, we've saved our credentials into the credentials file. Now we're going to start the Greengrass container. So that's everything that we need to create or download the Greengrass Docker container and allow it to set up everything it needs to function. This is using Docker Compose to run all of the services, but it's specified the Greengrass service. So if we take a look at what's in the Docker Compose file, it's got a number of services, including this Greengrass service. So all of these underneath aren't running, but Greengrass is. Now the README does discuss these other services. These are all ROS2. So discovery is It's a server that allows all other ROS2 nodes to discover each other. IoT Pub is the telemetry MQTT from the IoT Core example, and the mock pub is the telemetry mock data from the previous example. We can see this if we take a look here. So the mock data generator will feed data to telemetry MQTT through the discovery server. Then the telemetry MQTT will give it to Greengrass, which can then push it up to the cloud. And that's the installation complete. So Greengrass has just downloaded all of the software it needs to run within the Docker container. So we can carry on down here and start deploying components. Now the image here shows the components that we're deploying. So we've got the nucleus, which is the core. It's what allows Greengrass to function. We've got a client device auth component, which is what says whether a connecting thing is allowed to connect or not. That's what will say whether a robot is allowed to connect to our gateway or not. The MQTT broker, which allows us to do local MQTT, meaning that robots or other devices can pass messages through that broker to each other without needing a public network connection at all. And the MQTT bridge. That's a component that we will configure to take some local topics from the MQTT. This gives us the template and is allowing anything that's allowed to connect to publish and subscribe to all topics, locally at least. Let's add these two variables to the bash RC. We can stop that Greengrass container now it's had its first time set up and continue to use it for the rest. So as I just mentioned, this client device auth component allows some robots to connect, and which robots are allowed to connect is specified in this file that we've just created. So far, only one thing is allowed to connect, called the test ROS2 thing. We would need to connect other things, like thing name 1 or thing name 2, within that file to be allowed to connect other things. Continuing on from there, we've created our auth component configuration. Now we want to create our deployment configuration. These are all the components that are going to be deployed onto our Greengrass container, including the configuration for each component. So there's more information about what's going on here, but essentially we're using a couple of tools to automatically create the JSON escaped text needed to deploy everything through the command line. Otherwise, we could do everything through the console. Okay, once this is complete, we're ready to create the deployment. Now for this to work, we are going to need Greengrass to be running in the container. So I've allowed credentials for Greengrass to set itself up, but not for my CLI to be able to do anything. So I'm just going to fix that. Okay, and we successfully got the Greengrass Amazon resource identifier. Now we're going to run our Greengrass container and create a deployment into it. And then create the deployment. Ooh, deployment config file. So we've created our deployment, and now we're seeing a log from the nucleus as it starts to download and run those components we've requested. Now we can also see this in the console as these steps are telling us. And it's showing how to get to it and see what's going on. So let's take a look at that. We're going to Greengrass. We can click Deployments and see our active deployment here, which is still ongoing. and it says the deployment state's completed. So we're going to configure discovery for client devices, which means that any Greengrass server the client device is allowed to connect to, it will see if that server is available and then try to connect to it. To do that, we have to configure it to be allowed to connect to the Greengrass server, which is what the first part of this instruction set. So this creates an IoT policy that says that test ROS2 thing is allowed to discover the Greengrass servers. And then we create the policy and attach it to our previous certificate. Now our thing is allowed to do discovery, but it hasn't been configured to discover any core devices, which is what this next command is. Now our device has been associated with our Greengrass core device that's running in the Docker container. The last step is to tell the cloud how to tell the device how to find the server. Meaning when the device says, can you please connect me to a Greengrass server, the cloud says it's here. So that's what this step is. And it just says that the host address is Greengrass because the Greengrass container has a host name of Greengrass on this system and it's only connecting on the same system. So when we run this command, we should be fully configured to allow our ROS2 things to find and connect to our Greengrass container. With that, we're going to quit our Greengrass container and run all of our containers at the same time. That's all of the containers built, and now they're all starting up. The IoT pub container starts up faster than the Greengrass container, so it has to have a retry loop to make sure that Greengrass is ready for it to connect to. And with our connection attempt number 4, it's connected and starting to push that MQTT data up to the cloud. So let's take a look at it in the browser. We can go to the test client and our data is already appearing. Now there's 3 different networks here and they're serving different purposes. One is the AWS network, which is a public network that Greengrass is using to talk to the cloud. The second public network is separate from the first one because it allows us to disconnect it much more easily, and it's used by the ROS2 containers to find out which Greengrass service to connect to. That is, it's doing the cloud discovery using this network. It only needs it when it starts up. Once it's started up and connected to the Greengrass container, it no longer needs public network access. It does, however, need local network access, which is our third network. So ROS internal tree is allowing our ROS traffic to move between all the containers on the local system. That's what the 3 networks are doing. So after startup, we only need 2 of them running. So what we're going to do is disconnect the third one. And we can see that the log messages are still appearing. So IoT Pub 1 no longer has public internet access. It is giving its messages to the gateway server. The gateway server does have public internet access, and so it pushes them up to the cloud. And we can see the messages still appearing. Now our ROS2 robot can connect to the Greengrass gateway server and use it to pass messages to the cloud or to other robots in the nearby system. Let's recap what we tried to do here. Instead of taking one robot and connecting it directly to the cloud, we took a fleet of robots, theoretically, and connected them all to one server, which was connected to the cloud. It gives us some advantages, like being able to run our own components on the Greengrass gateway server, and it lets our robots talk to each other, even when the public network's not accessible. So here's a challenge for you. See if you can get a second robot running alongside the first, and get them talking to each other using local MQTT. Also make it so that they're both pushing topics to the cloud through the Greengrass gateway server. Thanks for watching, and I'll see you in the next one.